Okay, so as we look at lesson 1-6, part 3, it's the big one. We're solving 3 systems of equations. It is very doable as long as, 1, you stay organized. And you know what's going to be the hardest part is not making careless mistakes. Because like any math problem, what happens if you make one little multiplication mistake or sign mistake?
It
throws the rest of the problem off. Okay? So, is this very doable? But stay organized and don't make careless mistakes. Easier said than done, I know. So, I'm teaching with using elimination. And we need to pick a variable that we want to eliminate. Okay? We wouldn't all have to pick the same thing, but for the first one, we all need to go together. But we can either choose to eliminate x's, y's, or z's.
Z's.
Well, to me, there's an obvious one I would pick here.
Why?
Why might you pick z?
Because there's no numbers that are...
Okay. They already all have the same coefficient, yes?
Yeah.
And if you remember elimination we're set up where we're trying to get so that if we eliminate variables, they have the same. And since these are all 1z's, either positive or negative, I'm going to suggest on this particular problem that we eliminate z's. Now, I'm just writing this down as kind of a reminder that we're choosing to eliminate z's. Now, I'm going to number my 3 equations. This is part of my organization. Okay? So I'm going to number these 3 equations. 1, 2, and 3. I actually saw this textbook labels them A, B, C. So it'd be equations A, B, and C. I just do 1, 2, 3, and I make sure I circle them so that I don't let those numbers get mixed in with the equations. Okay, let's pick 2 of these equations to eliminate z. What are 2 equations that would be easy to, they're already set up to eliminate z?
The last 2. The 1 and 2.
I would do 1 and 2.
Yeah.
Because, and 1 and 2 are good to eliminate because we have a positive z and a negative z. So, I'm going to put them down here. 1 is 2x minus y plus z equals 14. And 2
4 equals 4.
Thank you. Yep, let's see right there, guys. All I was doing was recopying my equation and I already made the careless mistake. That would have ended my problem in disaster right there. Learn from my mistakes, don't do what I do. Okay, thank you. 2x minus y plus z equals 4. X plus 3y minus z equals 11. And we're going to eliminate, yes? My z's are already opposite signs. So since I have a positive z and a negative z, I'm going to add these 2 equations. Now, with that in mind, 2x plus x. 3x. Negative y plus 3y.
2 plus 2.
Plus 2y.
Nothing.
Z plus negative z. Eliminates like we wanted.
Yep.
Carry down our equal sign. And 4 plus 11 is? 15. Now, I told you guys I want to be organized here, yes? Okay, this is going to be an equation we're going to hold on to for later. I'm going to call this equation 4. Okay? Or if you're an AB, if you want to instead use, they were ABC, then this is equation D to you, right? Okay. Now, we need to repeat the same process we just did, but we need to pick 2 different equations to eliminate z. So, first time through, we used 1 and 2. This time we can use basically either 2 and 3 or 1 and 3 to eliminate z again. So we want to eliminate the same variable again. Which one makes the most sense?
1 and 3. Caden said.
And why 1 and 3?
Because it has a
Positive Z and negative Z.
Positive Z and negative Z again, right?
Yep.
So I'm going to write out, and I think I'm going to go right here. I should have room. So this time, 1 and 3. I'm going to write them out. 2x minus y plus z equals 4. 4x plus y minus z equals 14.
Hey.
My z's have opposite signs, so again, I am set up to add. Okay, they're going to cancel when I add, correct? Okay. 2x plus 4x.
6x.
6x. Negative y plus y.
Nothing.
Okay. This was not exactly supposed to happen. This is an added perk. Enjoy, right? Okay. Z plus negative z. Cancels. Okay. Carry my equal sign down. 4 plus 14.
18.
18. Now, in a traditional problem, so like next time we do a problem, there would still be an x and a y, and I would call this equation 5. Now, in this case, we just set ourselves up to solve this problem, yes? Okay, so I got pure luck. We'll take it, right? If we have 6x equals 18, how do I solve for x?
You divide by 6.
Okay. Excuse me. We're going to divide by 6. And we're going to get that x is 3. Okay. We have an answer. Am I done with this problem?
Nope, you gotta plug it in. You gotta plug it in.
Okay. We have to plug it in. Now, where's a good place to plug it in?
Oh, definitely the first one.
No. 4. Yeah.
Okay, are we seeing this? If you go back and plug into equation 1, 2, or 3 right now, it only helps a little bit, doesn't it? Okay? We need to plug it in somewhere where there's x and one other variable. 4 totally makes sense, doesn't it? Because it's x and y. So, we're going to use 4. And equation 4 is 3x plus 2y equals 15. I'm going to plug the x equals 3 in. So 3 times 3 plus 2y equals 15. 3 times 3?
9.
9 plus 2y equals 15. See, if I tell on myself, I made a careless mistake doing my answer key last night, or yesterday. I said 3 times 3 was 6 yesterday.
It's not.
I know. But that's what my brain said at that moment. So these are the careless mistakes to watch out for. Solving for y, we're going to subtract 9. 2y equals 6.
Yes.
Divide by 2.
Y equals 3. That's crazy.
What if they all equal?
Y equals 3.
Ka-chow.
Boom.
Okay. Now, am I done?
I don't think so. No! There's still Z.
Okay. We have x. We have y. We need a z, yes?
No.
So, now, how am I going to get z?
Wait, I know. I can answer this. I can answer.
Get an answer in.
Give it a try.
Do you plug in x and y into one of the equations?
Yeah.
Yes.
Which one?
Oh yeah, the first one.
Okay. Aaron says equation 1. Officially, what are my choices?
1, 2,
1, 2, or 3. At this point, you have to go back to something that has a z. So equation 4 doesn't work anymore. We've already used it and it's done. Equation 1, 2, or 3. Does it matter? No. Pick out of equation 1, 2, or 3,
One.
which one looks friendliest to you.
1.
Okay?
No.
So, if I pick equation 1, equation 1 is 2x minus y plus z equals 4. Okay? Plug in what you know, yes?
Yep.
So, we know x is 3. 2 times 3 minus y, which is 3, plus z equals 4. Focus on the problem, please. 2 times 3 is 6. So I have 6 minus 3 plus z equals 4. Like terms, 6 minus 3 is 3 plus z equals 4. If it's 3 plus z, subtract 3. 4 minus 3 is 1.
So then you have your x, your y, your z.
Okay. Now, on a regular elimination problem, how do we express our final answer?
Ordered pair.
Ordered pair. So we're going to do something similar, except it's called an ordered triplet.
Oh, triplets.
Think alphabetical order. So we're going to have x, comma y, comma z. So your final answer will be an ordered triple in x, y, z order. So in this case, it's 3, comma 3, comma 1. And that is what form the homework will be looking for.
How do you graph that? You don't?
We don't graph it in Algebra 2. It's three-dimensional, whereas, you know, you have x and y axis. The z-axis goes like perpendicular to them through.
Okay, whoa.
Okay? We don't graph it in Algebra 2 is what it comes down to.
That.
Okay? So z adds that third dimension that you can't easily graph on paper.
That's not. Is that calculus? Trigonometry?
I'm gonna say I don't teach it at the high school level, so.
Do you know how to do it? Oh, is that the sin cosine?
I mean, it's the same idea. I mean, you're going 3 on the x-axis, 3 on the y, and 1 in the z, but
So can you graph that into a graphing calculator?
I don't know. Okay, now, refocusing on the problem, not on the graphing. We followed the basic process, yes? Now, I will say this process was a little shorter on this problem because when we did equation 5, we happened to get 2 variables to cancel out. I can't say that will happen every time. Okay, so just kind of beware. We ready to try example 2?
Okay. Buckled in.
Example 2. Now, pick a variable that you would like to cancel.
Why?
I encourage us all to go the same direction here.
Why?
I personally pick Z. I would pick Y.
And why would we likely pick the y's?
Because they don't have any root.
They're all 1 y's, right? Positive or negative, 1 y's. So we're going to eliminate the y's. And again, that's just my reminder message to myself. Okay. Pick 2 equations
1 and 2.
to eliminate your y's. Okay, 1 and well, wait. I guess I forgot to do something, didn't I?
3. Why would you be so good?
Okay. You guys are referring to them by number. Awesome.
Yes.
I encourage you to number them, though, physically, like write the number down, because otherwise, I mean, this turns out to be a lot of work, right? This is not going to be the type homework problems that you can just look at the computer and answer. I'm going to expect to see work. Okay, you're going to have to do some work here. Now, so you guys said what, 1 and 2 to get us started? So 1 being x minus y plus z equals -1. 2 being x plus y plus 3z equals -3. Okay. My y's have opposite signs, yes. A positive y and a negative y. We're going to add those. So, x plus x.
2x.
Negative y plus y.
Cancels.
Cancels, as we expect. Z plus 3z.
2. 4z.
4z. Carry down your equal sign. Negative 1 plus negative 3.
-4.
Negative 4. And on that note, yes, the reason I put a line through my z's,
Make sure you know it's
because those are my z's, my 2's do not have lines through them. So just beware. Yes.
Do we number the new equation?
And what am I going to number the new equation?
4.
I'm going to call it 4. And again, as you guys get good at this, maybe you're going to be like, I don't need to number it. I'm organized. I know what's what. But there's a lot of numbers floating around here, aren't there? So my encouragement, my teaching style is, okay, let's organize, let's number. I'm an organizer here. So, okay. Now, well, I'm just putting a line just because I'm going to put my other one right underneath it.
Oh.
Last time I put it beside it. So we're going to repeat this process, yes?
Yep.
Yes.
We used equations 1 and 2 and found equation 4.
Yes.
We're going to pick a new combination and use them to find equation 5.
2 and 3.
I like 2 and 3 because there's a positive y and a negative y. So 2x plus y plus 3z equals negative 3. 3. 2x minus y plus 2z equals 0. My y's have opposite signs. So again, I am adding, yes?
Yes.
Could you use any combination of equations? Like, could I use 1 and 3?
You could use 1 and 3. Now, the trick with 1 and 3, though, is we'd have to adjust one of them because they're both negative y's, and they're not set up with the opposite signs.
You can't use 1 and 2 because we're using.
So, yeah. So, if you don't want to have to do any extra work, that's why I would encourage 2 and 3. Now, when we get down to this example here, we'll talk about the fact that there are times we're going to have to multiply equations 1, 2, or 3 by something. Okay? So, it's not a no, but it's not in your best interest here. Okay. So, x's. X plus 2x.
3x.
Y's. Y plus negative y.
Cancel.
Okay. 3z plus 2z.
5z.
5z. Carry down the equals. Negative 3 plus 0. Negative 3. And I'm going to call this equation 5.
Equation 5.
So, let's grab equations 4 and 5, and we're going to rewrite them and look at them. So I'm going to rewrite equation 4 over here. 2x, whoops, plus 4z equals negative 4. And I want equation 5 right below it. 3x plus 5z equals negative 3. Okay, so we started this problem off. We took equations 1, 2, 3, and we eliminated y's twice. We have 2 new equations now that we're working with. As you look at 4 and 5, this is your traditional Algebra 1 level elimination. Do you want to eliminate x or z here? Because that's our next goal, is we have to eliminate another variable. You want to eliminate x or z?
It's x.
And again, it's a personal choice, yes? You can either multiply and get what for x?
6.
6x, or you can go
20.
20z. So,
Alright.
I'm guessing you guys, the majority are going to say let's eliminate x's.
Yeah.
If we eliminate x, what do you multiply 2x by? 3. 3. What do we multiply 3x by? 2, and I would throw in a -2. Okay. Let's rewrite these equations, yes?
Yep.
After they multiplied. So multiplying the top one by 3, it becomes...
15x plus
Wait. 6x
6, I need it, 6x
plus 12z
plus z
equals
equals
-12. Bottom one, multiplying by -2.
-6x minus 10z equals 6.
Okay. -6x minus 10z equals 6. What do you notice about the x's?
Cancel.
They are opposite signs, so we're ready to add and cancel. 6 plus -6x.
Cancel.
Cancel. 12z
2.
plus -10z.
2z.
Easy.
2z.
Carry down your equal sign. -12 plus 6.
-6. Z equals.
Okay. Once you hit this point, we're nearing the end, right?
Yep.
We've done all the hard work. Do you see that we're ready to start solving?
Yep.
Once you eliminate here with equations 4 and 5, you're ready to find your first part of the answer. So if 2z equals -6, divide by 2, and z is
-3.
-3. So we have our first of 3 answers. Okay. Where do we go to get our second answer, do you think?
Oh, I think it's back. Number 4.
Okay. You can go to, you have a choice. 4 or 5 is where you want to go back to. And that's, obviously there's sometimes weird exceptions, but generally speaking, I would go 4 or 5. So it doesn't really matter which you go to. If I go to 4, if I go to my original 4, which was 2x plus 4z equals -4. And we're going to plug in that -3, yes? So 2x plus 4 times -3 equals -4. 4 times -3 is going to be -12. So 2x minus 12 equals -4. If it's 2x minus 12, I'm going to add 12. 2x equals -4 plus 12 is 8. And divide by 2. X is 4. Okay. I have 2 answers. How many do I need? We need 3. We need one more answer. I know Z. I know X. How do we find Y?
Plug it in.
Plug it in where?
I plugged it in.
Okay. So now we're going back to equations 1, 2, or 3. Okay? Your pick again. 1, 2, or 3, something that has the 3 variables. I kind of like Layton's too. The advantage of using 2, it's a positive Y.
Oh.
Now, am I saying you can't use 1 or 3? No. Okay? So if I use equation 2, which is x plus y plus 3z equals -3. I know a lot of you probably picked 1 because it's just x, y, and z, right? I get it. So I have 4 plus y plus 3 times -3 equals -3. Well, if I multiply, so I still have 4 plus y, 3 times -3 is -9 equals -3. Like terms?
Oh, we have z.
Okay. 4 and -9 are like terms, so I still have y. 4 minus 9 is going to be -5. So if I have y minus 5, I'm going to add 5. And y is 2.
Yes.
It's always a good day when I match my answer key.
We're not done yet.
There's one tiny way we can say we're not done yet. How do we express our final answer?
Put it in the triple.
Ordered triple.
I don't think that.
4 to -3.
We don't have that time.
Even if we don't have enough time to do the third problem, you're getting the hang of it here.
Yeah.
Now, I do want to start the third problem because it is a little different in our startings. Okay, so we are going to start it. Now, are we okay here? It's a lot, isn't it?
Yeah.
But it is doable, I promise. Now, here's what I'm going to tell you guys. The best way I'm going to be able to help you, don't come to me and say, I'm confused. I don't know what to do. Come to me with your iPad, with your original problem, and your paper that has your work worked out. Because the best way I can help on this lesson is to troubleshoot. Take your work, follow your work, and look for your careless mistakes. Because that's what I end up doing here. Okay?
So.
So.
Our work.
Well, I mean, you're going to want to, you're going to want to have your work. If you're going to come and ask for me, like, okay, I've already gotten it wrong once, can you help me find my mistake? I'm more than willing to do that. Okay? Because that's going to be the frustrating part. You make a careless mistake, sends the whole problem wrong. So, now, 3. Whether we get all the way through the problem or not, probably not. However, I at least want to talk about how we get to equations 4 and 5 here. Okay? What do you want to eliminate?
I don't know. I'm going to go add.
Okay? And here's the deal. It's not quite as obvious this time, is it? I would definitely go either X or Y. I would not go Z. Okay? But we're going to have to do a little more work here. So, if we opt to eliminate X's. Okay? Now, and again, I'm going to number my equations. 1, 2, 3. Is the numbering help, I hope? It's organization.
Yeah, it helps me personally.
So, I'm hoping. Okay. Let's get the easy one out of the way. What's the easy combo to eliminate X's first? 1 and 3? Because you have a positive 1x and a negative 1x. So let's go ahead and start with 1 and 3. Copy carefully. X plus y plus 2z equals 3. And equation 3, negative x minus 2y plus z equals 10. X and negative x have opposite signs, so we're going to add. X plus negative x.
Cancel.
Cancels. Y plus negative 2y.
Negative 1.
Negative y. Negative 1y. 2z plus z.
3z.
Plus 3z. Carry down your equal sign. 3 plus 10. 13. I'm going to call this equation 4. Now, we have to get an equation 5. So, we used 1 and 3 to begin with. We're going to have to go back and use 2 with somebody. We don't have any other option here. So, 2 and what?
3.
Okay, we have to use 2 with 1 or 3. And I would say 2 and 3 because at least we have a positive and negative. So let me write down my 2 and 3, and then I'll take you through the process. So 2 is 2x plus y plus 3z equals 7. 3 is negative x minus 2y plus z equals 10. I can't eliminate as is, can I? So, go back to basic elimination rules. What do I have to do to be able to eliminate x? (2x) and negative 1x. Multiply that bottom equation by 2. You don't have to multiply the top equation by anything. We're just going to multiply the bottom equation by 2. And I'm going to rewrite these over here. Now, I'm not going to name this new equation here. We're just going to use it briefly. So, top equation is still 2x plus y plus 3z equals 7. Bottom equation, when I multiply by 2, is now negative 2x minus 4y about plus 2z equals 20. And now my x's are opposite signs, and I'm ready to add. 2x plus negative 2x. Cancel. Y plus negative 4y. Negative 3y. 3z plus 2z. Plus 5z. Carry down your equal sign. 7 plus 20. 27. And I shall name this 5. So it took an extra step there at the beginning, didn't it?
Yes.
You won't always get neat, eliminations. That's fine. So I'm going to bring equation 4 up here and equation 5 up here because I want to be able to see them next to each other so I can figure out where I'm going next. 4 is negative y plus 3z equals 13. And 5 is negative 3y plus 5z equals 27. And now, what do you want to eliminate now, right? You can either eliminate y's or z's. I'd probably go with y's and multiply my top equation by negative 3, because then we already have a negative 3 down below, and that'll give me a positive 3 up high. Okay? So if I multiply that top row by negative 3, positive 3y minus 9z equals negative 39. Bottom row carries over as is. Negative 3y plus 5z equals 27. Okay. Y's are opposite, so we're going to add. We're almost there, aren't we? We're going to run out of time, just the wrong time. 3y and negative 3y cancel. Negative 9z plus 5z. Negative 4z. Negative 39 and 27. Negative 12. Divide by negative 4, and you know your first answer is 3. Now, I'm going to write it down here because some of you will want to finish that problem because you won't be able to stand leaving it unfinished. The final answer you will get, if done correctly, is 1, -4, 3. You would take z equals 3, and you're going to take it back to equation 4 or 5. You'll find y, and then you'll take z and y back to equation 1, 2, or 3, correct?
Yeah.
Okay. Now, you have a homework assignment. I put a whole 3 whopping problems of homework there for you. Because these are lengthy, yes?
Yes.
And when you make a mistake, there's all kinds of frustration involved. I will warn you. It's the best I can say. Don't make mistakes. Easier said than done, right? Okay? So, try those 3 problems. We will very possibly do some review tomorrow in class. I don't know. Because I may spend some of my class and time tomorrow doing some troubleshooting. We may want to go through one of the homework problems on the screen tomorrow. We'll see. I think I pushed off the due date on it until Friday. But if you can get it done tomorrow, you know, by the end of the day tomorrow too, that's good. So work on it. See what you can do with it. Bring me questions. And it's lesson 1.6. Part 3, elimination is how it should be listed.